Yeah, hi, I'm Jared Faris. I come from Columbus, Ohio, so not too far away. The last time I presented this was in Michigan, so I had Michigan on this and a bunch of like angry emoji. I actually don't care about Ohio State, but everyone else I know does. So I start with that. I work for a consulting services company called HMB. I brought some swag because I raided the recruiting office. So that's enough about that. But my background is, my role now is a little different. I manage developers, but my background is web development. I've been a web developer for most of my career, as well as full stack and other stuff. And about 5 years ago, maybe, I became a Microsoft MVP, which was interesting because I didn't own any devices that could run Microsoft software. I mean, I guess Office. But I went to Microsoft to their campus. I had a Mac. I thought I'd be kind of an outlier. Internet Explorer was still the thing. So I was an Internet Explorer MVP with a Mac. It turned out they wanted to help make the world more of like a standards compliant place, and so they were actually pulling in people who were not part of their kind of clique. And since then, I've got to talk to all sorts of people who are on the standards committees, so part of W3C or some of the other ones, and we'll talk about those, and learn a lot about how web standards are developed and all of the dysfunction therein. And so this talk is about, if I work with my clicker, is about that. It's about kind of how standards emerge, who are these kind of mysterious bodies behind the scenes that are developing these standards, and what are some of the things you should care about. So it's not a talk about frameworks like on Angular or React, but like core fundamental function or technology behind the web, and some interesting stories about how we got there. So I hope you'll learn some things, but I'm not going to deep dive into code on anything in particular. I think there's maybe 2 slides that have anything even with code on them. It's more about like what's out there, why should you care, and my hope is that you would then go Google it and figure out if you're interested. And so the art does not get any better than this. It's the best I can do with a glass of bourbon and an iPad, but it works. So there we are. So kind of the premise behind this. So we think of technology as, I say usability here, I don't mean, this is not going to work on the monitor, I don't mean usability in terms of like end user usability, but we think of technologies as evolving and giving us as developers more capabilities, maybe is a good way to say this. And over time, technology companies innovate and we get more stuff, and it's an upward line like that. But in reality, it's like this. Over time, if you've been doing web development for a long time, at some point in here, we went backwards because of things like Webpack, where suddenly it became incredibly complicated to do anything. But over time, the trend is still vertical. And so while we're talking about this, I want to talk about some of the places where we get into those kind of weird, feels like we're going backwards or things are super complicated, and the why behind it, because it turns out that some of these totally crazy ideas or decisions that get made actually have rationale, and I'll tell you some stories that you'll, if you haven't heard them before, you'll be shocked by. So web development's accelerating, right? It's moving faster and faster all the time. It feels like the pace of change in general in technology is increasing. And so, while we're in here, there'll probably be like 2 new JavaScript frameworks, and one will get deprecated. And Angular will be on like Angular 45 or something, and they'll skip numbers for no apparent reason. But it is actually getting better too. So it used to be, who here has been doing web development for like 10 years? Anyone? Remember how painful it was to get something to work in any 2 browsers for any reason? Right? And it was impossible to even figure out why something didn't work or didn't render right. It actually has been getting better, and browsers tend to follow standards now, and there's more functionality getting added in a kind of controlled way. So that's good. And we have, and Sparkbox is a good place to talk about this, we have things like responsive web design, which is some of the Sparkbox people were the first people I heard about that from. We have, things just work on every device, right? So one of the interesting things about the iPhone was suddenly everyone expected every single website to work on a tiny little screen that it was never built for, right? It was built for IE11 on a desktop, and now we want it to work on our phone. But that's been good. That's caused us to build more accessible sites. Things that work in multiple modes of operation tend to work for more people, which is great. They tend to be faster because even though I have an iPhone 10, it's more powerful than the first computer I had by a long shot. You still get limited connectivity, right? You still have, there's all sorts of situations where things aren't great, and as developers, we've been thinking about that. So it's better. And these things apply even if you're in the enterprise. So who here works in with like an internal, like a big enterprise shop or builds internal line of business apps? Is that no one? So that's my, okay, one hand maybe. That's been my life. So my customers a lot of times are building the systems they need to make their business work. And even they still expect that it's going to work on every device. And so who here works in kind of customer facing, who here like builds public websites or Okay, so more hands. Very much the case there, but it's the case everywhere. So we're going to talk about a bunch of standards and a bunch of things coming out, and hopefully they'll be applicable to you. And my hope is that you may have heard of like 90% of them, but you'll walk away with that 10% that's still interesting. So we're going to talk about how the web literally works, and by literally I mean figuratively. So the internet's a series of tubes, right? So you're up here and you're in the cloud, and that's the cloud layer. That's a modern architecture. And then somewhere, some stuff goes through tubes, and you get to your servers, right? So that's how the web works. And so there's a bunch of innovation happening at all these places. So there's innovation in the browsers. We're going to talk about like some new like controls coming out in HTML. That's great. There's things like web components that are changing slowly how we can do things. JavaScript is innovating constantly. We'll talk about service workers, which sit kind of in this middle thing. Is anyone using a service worker today? Or building a progressive web app? Are you? Nice. Okay. Awesome. This is the thing I'm most excited about, like in the web right now. I'm super excited. Offline mode, right? So it works anywhere. And then we're going to talk a little bit about the communication layer, the pipes, the HTTP2. And then we're going to cover a little bit about security, and that'll be that. So what we're going to do, and this is my favorite animation. This is the best I can do. We're going to take a little bit of technology, a little bit of process, and we're going to shake it together. And I'm just going to click back forward, back forward, back forward. Look at that. Yep. And that's going to be what I do. So, thank you.
Is that like blood dead?
That's supposed to be like a Cosmo or something. Yeah. So we're going to talk about HTML features and a bunch of things that are coming out. Some of these you can use now and kind of the evolution of HTML. We'll talk about CSS and particularly Grid. Is anyone using Grid yet? Grid's awesome. And CSS variables and a few other things. We will talk about progressive web apps and all the things that go into those and kind of the changing evolution of JavaScript, which I think is interesting. And we're going to talk about HTTP2. And we'll talk about these standards, few standards bodies. So W3C, the World Wide Web Consortium. WHATWG, that's actually their logo, not like a missing icon. We'll talk about ECMA, IETF. That's not really a group. But we're going to talk about some of these groups too and what makes them tick. So hopefully, my experience has been most developers have no idea what's going on behind the scenes, but all of it's public. So I'm kind of a geek about it. So I'll share some things that I think are really interesting about the how and the why, not just the what. So let's start with some HTML stuff. So even HTML is interesting because HTML is a standard published by the W3C, and it's also a standard published by WHATWG at the same time. So it started with W3C, and they are a standards body, and they're kind of an interesting group. So they, when I looked up the number, they have 474 members, and it's all the big companies, Microsoft, Google, Oracle, and then you get companies like who have a big stake in the web, like eBay or Intuit, and they buy in. And so in 2014, I don't have any more recent numbers, it was $68,500 to be a member organization. People in academia can get in for cheaper, individuals can get in. I don't know how the pricing works, but you have to pay to be there. And they have events, and they've been meeting for 20 plus years. So all these, these brands are here. They've been meeting for a long time. And so it's 20 plus years, which means the web's a millennial. So that's kind of interesting. And they work remotely. So there's an interesting article. I made a bit.ly link, Rules the Web. The New Yorker put a very long article, which is classic New Yorker, about how these groups work and how they meet. If you're interested, I think it's a very interesting read. So they meet together in person, and they would build these standards, and the standards were kind of slow moving. And like Microsoft sends people to these events. So like somebody on the team goes to Japan, and they meet. And so that's how they've been for a long time. So in 2011, 2012, they didn't care about HTML anymore. So they decided they were going to focus on XHTML, because that's clearly the future. Does anyone even know? HTML was dead, but the problem was that browser vendors kind of didn't agree, because they had millions and millions of sites actively using HTML. So W3C basically told them, if you want to keep working on that, you have to go somewhere else to do it. So they forked it, and they came up with this WHATWG group. And they're interesting because they said they're going to do things a little bit differently. They're going to meet, or not meet, they're going to go public. Everything's online. Anyone can be part of the discussions. They don't want to make it so that there's like a high barrier to entry. And they were going to have an evolving standard. So we have HTML5, But they said, well, we're done with that. We're just going to have HTML. And as we get consensus on things, we're just going to update this. And it was interesting because the browsers were doing that anyway, right? They were innovating. They were building stuff. So at this point, if there's an HTML 6 or 7 or 8, it's going to be marketing by the W3C rather than anything to do with kind of the web. And these are the web standards bodies, and they swear a lot. So the reason I like to tell a story is it's complicated. Right? We have two groups now. And there are companies, there are people who are in both groups. There are some companies who only interact with one group, and that's the foundation of like everything we're doing as web developers. So that explains a lot of our mess, right? So now we have WHATWG, and we have these three founders that started it after a workshop where they had these concerns. And everything's on GitHub now. And there's, I think, mailing lists for some things too. But you can go out there and read it. And you can read about the discussions, and you can see people get agitated. And you can even see points of view that are different. Because Apple is clearly optimizing for something very different than Mozilla, right? Apple makes a ton of money in the App Store. It's weird. Their progressive web app story is really slow. That's strange. I don't know what Opera does at this point. And they're there, but yeah. And I think they're Chromium based now too. So these groups are all trying to drive consensus or trying to drive standards. But this is a quote I like from Ian Hickson. He said, "Consensus is not a useful value in web spec development because it doesn't actually reflect the power dynamics at work. In practice, implementers, so that's the browsers, not spec editors, not authors, not users, I like this, not interested bystander standardistas." I think he's making fun of professors there, probably. But the W3C and WHATWG have no power. WHATWG is built around this realization. The W3C, however, was built in the assumption it does have power. That's how you end up with XHTML2. Basically, what he was saying is that we want to get everyone's input, but at the end of the day, if a browser is not going to implement a feature, it doesn't matter how great a feature it is, right? If there's not going to be an implementation, or if it's not going to be implemented everywhere, it doesn't matter how brilliant it is. If it's implemented everywhere and it's garbage, like much of the web, it becomes a standard. That's just kind of how things happen. So they're not consensus-based, but they do try to find things that will solve all the different stakeholders' kind of needs. It's an interesting group, and if you're interested in that, go check it out. So you had W3C still doing their thing. They kind of take snapshots now. So WHATWG has this evolving standard, and it seems like W3C periodically says, yep, whatever you have there, we're going to stick a title on it. We're good. There's more to it. It was interesting for a while because like Microsoft would only interact with W3C, not WHATWG, because W3C has, I guess, like IP sharing agreements. So Microsoft didn't want to put something in a body where they might get sued later for contributing it. It was about a year and a half ago they announced that they support OpenStan. So these groups are sort of kind of merging together again. So that's kind of where we are now. So you have HTML, and you have HTML5. And that was like a huge shift, and it took 400 years to come out. And then you had HTML 5.1, and it was just a bunch of little features. And these are things that I still don't see people implementing. I'm not going to go over all of them, but there are things in HTML that people just don't know about right now. So like, it's not universally supported yet, but like everyone who's built web apps for long enough builds context menus or builds things that make it feel like a desktop app. And they started saying, well, anything that we're going to do 1,000 times, let's start building into the application. The context menus or expanding details panels or letting you control spell check and validation from an API. This is the kind of stuff that they're innovating. Date pickers that feel native, so you don't have to use like 16 different jQuery plugins or something else to do date pickers. The stuff they're innovating in now is user experience. And so if you use the date picker plugins, and this only works if you support kind of evergreen modern browsers, and you're on a Windows device, it feels like a Windows date picker. You move to iOS, it feels like an iOS date picker, and you don't have to build that in JavaScript. So one of the interesting things I learned from talking to, he's no longer with Microsoft, but somebody who was on the W3C, one of their committees, was that they were looking at what we were doing as developers out in the real world and saying, why are 10 million people implementing that custom every time? Why don't we just build it into the spec? And they called it paving the cow path. Like somebody has kind of made this path through the wilderness, and it's a dirt path, and it's kind of windy, and we're just going to cut a clean path through and pave it. So a lot of what they do here is kind of, that's a usability from our standpoint, making our lives easier to streamline the stuff that we build every day. There's a bunch more stuff, and it's kind of universally supported. And what you see is that as the web's kind of evolving and you get 5.2, 3, 4, 5, different browser vendors care about different things, and they pilot one of these features, and then they kind of test it. They usually they put it behind like experimental flags. They get feedback. They bring it back to the standards body, and then a consensus is kind of drawn, and it becomes part of the spec. And you can see these evolve. And if you go on their forums, you can actually see there's like phases for these standards, and you can see as things evolve. So they do two things. They build those easy-to-use things, and they also build plumbing. When we get to service worker, that's some of the plumbing behind the scenes. So the question with anything on the web is, can I use these things yet, right? And the answer is, I don't know. It just sort of depends. It depends on the feature. There's a number of good sites. W3C has one about the HTML5 implementation guide. That graphic is super old. I think a lot of those are green now. But you can go out and see, like, if I have to target certain browsers, which ones will work. Or you can use polyfills. Is everyone familiar with that term? Because it's not, that's like a huge takeaway. Polyfills. So there's polyfills for everything. And in fact, nowadays, the browser vendors ship those. So if you have to support something old and they want to push a feature forward, they'll give you the JavaScript to make it work on the old browser because they want to drive that consensus. So I think that's really cool. And then you get like, so HTML 5.2 came out and it had some features, and native dialogues was one because they're like, hey, everybody builds modals. How about we just make it so you don't have to build custom modals? We'll let that be supported. So they're still innovating. And you know, I don't think that's universally supported yet, but this stuff's coming. So there's a bunch of stuff around kind of front-end experience that they're building. So that's cool. Then they're building stuff that's more kind of like core to like what we code and what we're building. So the thing I'm most excited about in the CSS space is CSS Grid. Who here hasn't used it? Eventually I have to take this out of a talk because everyone's used it. So no, everyone's used it? That's great. So I will go through this quickly, and if you haven't, I'll send you the slides. But the coolest thing about CSS Grid to me was when we think about a page layout, we think about, hey, stuff's going to shape like this, and then you can describe it in your code, well, your CSS, like, hey, there's a header across the top. Hey, there's a sidebar on the side. When Flexbox came out, there was like a million conference talks about how to do really simple things with Flexbox, and I think people walked out of the sessions feeling even more confused. Flexbox doesn't go away, but it's used for different things. They said everyone's trying to do grid layouts. Like everybody's downloading Bootstrap. So everyone's adding like 300 kilobytes of CSS to their site for a grid and maybe nothing else. Why don't we just bake that in the standard? Right? So they took that feedback. They also said, hey, everyone's using Sass and less. And one of the big things they have is variables. Why don't we just build that in too? So you can use reusable bits of code in your CSS. And there's going to be new things coming down in CSS to take even more of the features from these preprocessors and just build them in the standard. So CSS is innovating. And if you're still, I mean, there's nothing wrong with Sass and less, but you may not need it at some point if you're using those. So any questions around these features? I can talk about the features, but more just kind of exposure.
And the recent announcement about nested CSS is really native too.
Yeah, so that's a huge, good point. So a really, really nice benefit of using a Sass or a less was you could say, okay, I have an ID, and I don't want to put that ID in front of every single style I have. I can embed blocks of CSS and apply things, and then you could use variables. You could kind of sprinkle those through. That's all going to be built in. So interesting thing. So CSS 3 is sort of the last CSS. I'm not expecting you to read this, but CSS 3 has a version. What's happening now is there's this whole list of features they're working on, and the individual features now have their own life cycles. So they move through, I think it's like stages 1 to 4, and they'll get implemented in browsers and shipped individually versus a giant bulk release. So this was from the CSS site, and it's just kind of their current list of features. And I should have put a link up to it. But the cycle's changing, so it's not going to be these like multi-year releases. It's going to be evolving kind of like HTML. So you'll see these things come online as they get implemented. So lots of stuff coming. Next thing that is interesting and has been, web components are like Fusion. They're only a few years away, and they have been forever. But there's something that you can sort of start to use now, and there's mixed support, but there's something that's pretty cool, and the pieces of this are starting to affect other parts of web development. So web components are this idea of, you're going to build a bunch of things that you want to reuse. So you might want to have a development team that's building like widgets for your site. You might have another development team that's assembling content, right, and putting it together. Could you build these components in a way that they can be imported and applied and maybe styled and then maybe sell them on a marketplace? Or if you're in a big company, maybe your core team builds your data grid stuff, and then 3 different products can apply it, and it's going to look a little different in those cases, but they can share things. So they have HTML. I'll show a real brief example of these. HTML templates, so reusable bits of HTML. A shadow DOM, which sounds kind of mysterious. It was basically a way for them to bake in functionality into these. custom elements so that once somebody, and I'll show you one of these, once somebody wants to put your whole component on a page, they can just use one HTML tag. And it used to be HTML imports, but they've moved to ES6 modules, but a way of doing export-import of this stuff. So there's a whole bunch of things on this. If you've heard of Polymer, that's a library to make this easier. You could do a whole talk on this, but this is an area that moves forward and backwards. It's kind of like the non-straight line of innovation that I saw earlier. But these are moving, and the coolest place if you want to see these in action is actually YouTube. And I'll zoom in on this. So YouTube uses these in Chrome, and they use Polymer. Anytime you see a tag with, I want the laser pointer. Nope, I can't use laser pointer and zoom. Okay. So anytime you see a tag that has hyphens in it, it's a web component. YTD video renderer is a web component, and on the YouTube page, it applies it over and over again. So you can actually dive into the YouTube page in Chrome and kind of see how this is working. And so what they did is they said, okay, let's have our video component, and let's make, I can't look at that screen, let's make each of these be a component that we can drop in and then bind it to some data, which is something we've done in JavaScript frameworks forever, native to the web. And then if you have a website and you're consuming YouTube, the goal eventually would be you just pull in their web component, drop it in your page, you're good to go. These are cool. My favorite part of web components is that if you use Polymer, their version of Shadow DOM is called Shady DOM, which I thought was awesome. So web components have browser support that's pretty good across the board, and there's polyfills for, this is from yesterday, so this is up to date, polyfills for Edge, but this isn't going to matter soon, and we'll talk about that in a little bit. With me so far? So a bunch of web stuff, right? And then where I get excited is JavaScript, everyone's favorite topic. So I will start with ECMA, though. So ECMA was a standards body formed in 1960 to standardize paper tapes for computers. Love it. The European Computer Manufacturers Association. Apparently, we had paper tapes everywhere, and none of them were compatible, and somebody had to fix that. They became a standards body for a bunch of other technology, and in 1996, Netscape gave JavaScript to ECMA because they didn't want it to be a single platform thing, and Microsoft had spun off JScript, and they were worried about a web where it just partitioned and went everywhere. So they made it a standard, and they called it JavaScript. This is a quote that I love. This is from Brandon Ike, the guy who invented JavaScript. He said, "ECMAScript was always an unwanted trade name that sounds like a skin disease." So that's really nice. So the group, if you want to see how their standards are formed, it's all on GitHub. It's called TC39, and they're the standards body for ECMAScript. So this is the history of JavaScript, and I'm sure you can read that. So zoom in a little bit more. So in 1998, 97, ECMAScript 1 is born. 99, so a year later, ECMAScript 2. 99 to 2009, we were on ECMAScript 3. So a 10-year time frame with basically no innovation. 2009, ECMAScript 5 came out. A year, that ran till 2011. 5.1 came out, which was like they updated documentation to be more accurate, so that was really exciting. And basically nothing happened again until about 2015. And what I think is interesting here, I'll go back, these little ticks at the top, these are when browsers were released. Every 10 years, we get a new browser, and that's basically it. Because those things are so freaking complicated that it takes that long to build them. So in 2015, they changed what they were doing, and I thought this was really interesting. They said, Edge is the most recent one that came out there, we are not going to take 10 years to finish a bunch of features. We're going to go to a yearly release cycle, and similar to all these other standards groups, we're going to iterate on things. We're going to push different specs through stages, and you can go on GitHub and watch these. And then what they said is every year, whichever ones are done, we're going to ship. So ECMAScript 6 had a ton of features, or ECMAScript 5 rather, no, 6 had a ton of features. And a lot of them were kind of weird things that library maintainers would use, and then they were iterating after that. So I'm going to talk about two that are interesting, but there's a bunch of other stuff baked into this. The double asterisk operator, the exponentiation operator, like basic language functions, but then I'm going to talk about array.includes because this is a really nice story. So
Jared, real quick, we got ECMAScript 6.
Sorry, 5.
5 was a ton of features. 6 was those two features. Sorry, but yeah, go ahead.
So they changed it to like the year now.
Yeah. So okay, good point. So 5 came out with a bunch of features. 6 had 2 features, but 6 became ECMAScript 2016, and they are switching to a yearly name, so you can keep track.
Skip is, 6 is 2015, isn't it?
It might be.
Okay.
Yeah, yeah, you're probably right. But now you'll see them referred to as ECMAScript 2018, 2019 as well. So 6 had these 2 features. One of them took, I think, all of the time it was required to build, and the other one they snuck in an exponentiation because they felt bad because of only having 1 feature. So array.includes, there's an interesting story there. Has anyone heard the story?
No.
Okay. So it was originally called array.contains because there's other languages. Anyone do Ruby? I think Ruby has a .contains. A lot of languages have that functionality. It turns out that there's this tool called MooTools from back in the day. Anyone work with this? So MooTools had an array.contains. MooTools runs on something like 4 or 6 million sites still that have not been maintained in like 15 years that are still running, and whoever maintained them doesn't work at that company anymore. And their array.contains was not compatible with the new standard. And if they shipped the feature with that name, they would suddenly break millions and millions of sites that no company was ever going to be able to maintain. Just boom, gone. So they decided on a different name, and the quote that I heard one of the maintainers say is, one of our guiding principles is we do not want to break the web. And I thought that was interesting. And these are some of the quotes you can find in the mailing list. This was a really heated nerd argument about which of those 2 words to use. And the quote that I saw from Jason Orndorff from Mozilla was, "You're telling me I should ship a browser that chokes on thousands of websites that work fine today. That'd be bad for our users. I'm not planning to do that." So now one of the browsers said, you can ship that feature if you want in the spec, and we're not going to implement. Patching 3.5 million websites is not a small fix in any relevant sense. So you can see how complicated these things are, even naming something. Well, naming is always complicated. But if you get one major browser that says, you can do it if you want, but we're not going to build it, what's the point of your spec, right? So they had to iterate on this. Now there's a more recent example that I absolutely love, and I hope some people have heard about this. But I don't know if I have animations of it. Yeah, so let me preface it before I jump forward. So they want to add an array.flatten to JavaScript. So take an array of arrays and kind of smush it down. And array.flatten is going to break the web. So Brian Turleson, who was at the time the editor of TC39, he put this poll out on Twitter. Adding array.prototype.flatten to JS may break the web. The proper fix is to rename it, smush, e.g., change default depth to infinity, hack all documents all domains, or 69% said break the web. Developers are terrible people. Everyone said that. And so the best thing about this is people got really, really excited about that first option because he said, for example, smush. They thought he was serious. That was the choice. And that became there's all over the internet about all these developers and standards bodies saying, we will not build something called smush, blah, blah, blah. And so another group came out and built a library called prevent smush. So you put this, it was like a 1 line of JavaScript. You put it into your site. They wanted you to ship it to production because if you put this library in your production large-scale site, and we'll have a compelling case for TC39 to not break backwards compatibility. So they wanted you to put prevent smush in so that major sites couldn't use smush, so that they couldn't break the web to prevent smush. So I love that. So you had 2016, and that's why I think you had two functions come out, because 99% of the developers spent all their time on this, and somebody snuck through a basic function. We're iterating yearly. 2017 had a few things. Asynchronous functionality came in, and lots of little stuff, which is not an official feature name. But there's sites out there where you can track this, so you can see the current state of ECMAScript. And just to give you a sense of how they're iterating, because async's the exciting thing there, and things about how strings work. Oh, and I should make this bigger. Things not breaking because you left a trailing comma in. That's an amazing fix for developers. 2018 had a bunch of stuff. Some more iteration on async, some more regex features. 2019 has some stuff around flattening and improvements for JSON, kind of quality of life things. So when ECMAScript 5 came out, tons of features. Now it's sort of hey, we're going to ship a few, whatever's ready. Whenever they have the cutoff, we're going to ship. So you got a sense that JavaScript developers swear a lot too. So now we're going to pivot to something that I think is interesting. So all those things were core ECMAScript JavaScript functions. So they're part of the core language. That means that they work in the web, they work in Node, they work elsewhere. But W3C also owns a bunch of JavaScript. Because if it interacts with the DOM, it interacts with your page, it's not part of ECMAScript. It's the stuff that the web pushes in. Node has other things that interact with like the file system that aren't part of that. So they, just a few years ago, introduced fetch. So anyone ever actually write XHR? Does anyone even know? Tell me what XHR stands for. No. Yes?
XML HTTP request.
Nailed it. I'm sorry you know that. Did you ever have to write any on your own, like from scratch? Yeah. The reason jQuery took over was two things. One, it had that fancy selector thing, and two, it had a .ajax that just worked because XHR was such a nightmare. Fetch came out to kind of fix that. So the way we did Ajax was kind of a hack. So I think I made this. Yeah. So the way we did Ajax before was a function of Microsoft wanted to build Outlook Web Access early on, and they needed some fancy, quick interactive stuff to let them make it feel like a desktop app. And so they hacked in just this garbage protocol, and it worked. And OWA early on, for anyone that lived in the 1920s, was really cool. And it worked. And then Netscape said, well, people in the enterprise are dropping our browser because we don't support that. So they shimmed in their own XHR. And the standard came from that, kind of emerged from the garbage that they had, some developer at Microsoft hacked in on a Friday night. So we had that for 20 years. They finally released a new promises-based way of doing Ajax called fetch. And what's interesting about this, so if you're reading it, you tell it, give me a resource, I have a method, here's the body, here's headers, and then do something else with promises, which is how modern JavaScript's being written anyway. Then the browsers implemented the rest of their pipeline on this. So the fetch method that you can write in JavaScript is the same as the fetch method of an image loading on the page. It happens in the browser, but it's the same pipeline. There used to be there was 5 request pipelines, and you didn't know which one was going to happen. They all run through the same pipeline now, which will be relevant here in a minute. So, so fetch is the new promises way of doing Ajax. It does everything XHR did, except it's not cancelable, which is another interesting story. It's not cancelable because promises aren't cancelable, and promises aren't cancelable because a gigantic fight on the internet. So Dominic Demicola was a Google guy. I don't know if he's still there. He had the cancelable promises spec. He was the one advocating for it, and you can go on GitHub and read this. And the fight was so angry and agitated, and other people in Google didn't want to build what he wanted because they thought promises were a dumb idea to begin with, and we're not going to build any more features. And at some point, he just rage quit, said, I'm done, we're not going to do it. Google's not going to block it. Other people I work with aren't going to do it, so we're done. So there's no cancelable promises right now until somebody else picks up that mantle, which means fetch can't be cancelable. I have met, I think, one person who actually had a use case for that, but it's not there. So, and it's because people and their different agendas and fighting. So Chrome said they're not going to build it, and Chrome powers, 80% of web browsing, so might as well not put in the spec. So fetch is important because fetch changes the way we communicate between the browser and the server. That's supposed to be a server, not like a weird cupcake. And so fetch sits in the middle there, but because the entire browser pipeline uses it, we can hijack it. So we can use service workers, which are sort of like your own man-in-the-middle attack. So service workers came out and said, if we gave you a JavaScript file that you could include that let you interact with fetch, you could do some interesting stuff. They said, okay, you know what? You might build your site to assume you're always online, and just everything you get, every image you get, every CSS file you get, every API call, real time. But we can have a service worker in there that might do intelligent things like, hey, you don't need to load this image every single time. I'll cache it somewhere. Or an interesting case I see is people that build dashboards that have to update in real time. You could have it pull and say, you know what, if I'm getting real-time updates, let the requests go through. If the last minute's worth of requests haven't seen any changes, dial back my requests and just return fake responses every 30 seconds, just to slow down the pull on the server. Get a real response, speed back up. But you can do that without changing any of your front ends. So you have a legacy web front end you built 30 years ago or something, and it works. You can add a service worker without changing any of that code and modify network behavior. What's cool about this is you can make any site be fairly offline friendly. So if your users are now suddenly in areas with limited 4G or something, you can add a service worker to still give them some experience when they're offline. Or you can reduce network hits and that kind of thing. And so that allows you to build a progressive web app, which is not.
The service worker is kind of like a client-side proxy
Yeah. I would say I was always thinking of it as like a JavaScript middleware, but like it's a proxy server that sits behind your front end code and can monitor and do things to your network traffic. So that proxy server is a good way to think about that. And they added a cache API and some other stuff to support this, and in something called I forget the storage DB thing, but they added a storage mechanism there too. So this enabled progressive web apps. These are not a web standard. This was a Google marketing term, but it's just stuck. So it came from Google. But the idea behind a progressive web app is it's an application that it progressively enhances, which means somebody on an old device gets the behavior they had before, and as your device is capable of more stuff, like if you have a service worker, we'll add it. If you support saving to the home screen, we'll add that. And so it adds on progressive features as it goes. It has to be responsive, their definition at least, but that's kind of modern development. It has to support offline. They recommend it loads quickly. And then one of the things that is starting to get rolled out is the ability to add native style functionality if you're on a device that has it. So here's the example. The best PWA I think out there for demoing this is it's mobile.twitter.com. This is actually so performant that Twitter is sunsetting a lot of their native apps, and they're actually just using the mobile app under the hood because it works that much better than the native. They rolled this out, and you can go and look at their code. They have a service worker that's like, I think I said it was like 200 kilobytes. It's huge. Seriously crazy stuff that's in there. But the idea behind a progressive web app would be, the ideal, which is it sort of works on a Samsung device, not many other places. You go to Twitter on your phone, and it loads up, and it's a nice mobile experience. And you go a few times, and it says, hey, you're here all the time. Can I save you to the home screen? So you do. You get an icon, and it looks like an app. You tap that, it loads up, but there's no browser Chrome around. There's no frame, right? It just loads up, looks full screen. And maybe it turns on some more functionality. So you're loading in app mode. I'm going to go prefetch I'm going to prefetch the next 30 pages of content. So if you're scrolling, but you're like on a subway and you go underground, you can keep scrolling because it went and retrieved that data. Or you're offline and you send a message. I'm going to put a little like red 1 here or something and tell you, you're offline, but when you tap that and you're back online, I'll send it because you have offline sync is now a feature in these progressive web apps. So this is kind of the future. This is the most exciting thing I see in web development today because you can make any site work better by caching a lot of resources. If you can make a post and a GET from the server respond almost instantly, the whole need for using these like crazy SPA frameworks that build up this like really nice user interaction to avoid a GET and post from the server can go away. A lot of the apps that are out there, you can build them in like HTML with minor bits of JavaScript and a service worker now, and just abandon some of these frameworks. You might use the framework for your really complicated app that has a lot of interactions, but that's not a lot of the web. So the stats I saw from Twitter were when they went to this PWA, a 65% increase in pages per session. Those might be points. No, 75% increase in tweets sent and a 20% decrease in bounce rates of people bouncing off the page. So those are big stats, right? So that's pretty impressive, right? Starbucks shipped a PWA, you can buy coffee with it, right? So if you're not doing this, this is something like you should go and learn more about PWAs. So I have a kind of example, but I think we'll just jump through it because it's a little bit of code and this is gonna be hard to read, but I want to give you a sense of how complicated. I built my first PWA was for a conference, and I had a little HTML looking bomb thing and an LED on a table so I could show push notifications through the cloud to it. So you would hit something on the table physically and it would light up. Let me zoom in and just show you how easy it is to build these. There's only a few components you have to care about to get started. So your service worker has a few things going on. It has events that it'll care about. There's an install event. There's a couple others you care about. And then you're going to do some stuff. And the most common thing you're going to do is use this caches API that's out. And you'd have an array of things. And you say, cache these things. And then what the service worker would do afterwards is on a fetch, you would just hijack the fetch event, say, hey, it was a GET, or if it's to this website, or if it's something else, respond with the stuff in my cache. This could be responding with, I've seen service workers that actually produce fake results. So an old application that no one really had the code for needed to do something different, and they actually created new entities in here. So call a new API, a new version of the API. We're sunsetting the old one, but we don't really want to fix the front end. I'll map what the API actually returns to a different thing. So it starts at the service worker. You do some install stuff. and you hijack this fetch event with basically your own man-in-the-middle attack. And that's kind of it. There's support for offline. There's some more stuff you can do with push notifications, that sort of thing, but we won't dive into all those. So really, really powerful. Totally take that home. The next thing, so that's what I'm excited about right now. The next thing I'm excited about is WebAssembly. Is anyone doing anything with this? It seems it's super new. Okay. So WebAssembly at MVP Summit was like all the rage because there's this .NET thing people are going crazy over. WebAssembly is a binary instruction. I don't know what that means. Whatever. What WebAssembly is a way to take other languages and compile them to something that will run in the browser. So you can write stuff in JavaScript. You can use things like TypeScript that compile JavaScript. But a lot of development is not done in those languages. What we do today is we code JavaScript, right, and then we just ship it to the browser. And then we include 400 NPM packages, and now there's a crazy build pipeline, and it's super complicated. But what you can also do is not build JavaScript, and I was too lazy to draw like a Java icon and C# icon, but build other stuff, compile it into a bytecode, take a little bit of JavaScript to include that in your site, and run that on the web. So the examples of this would be, the examples I think are kind of cool. There's a company, I don't remember the name, they're doing machine learning stuff, and they have these C++ libraries in machine learning. They can compile those to WebAssembly and run them client-side. So if you're using a client-side like Google Write and you're building a document, your app could do intelligent things to learn about your writing style without having to make a round trip to the server, and they could ship that as C++ to the browser. And the JavaScript is basically like a module import. The import's basically the same kind of concept as the imports from web components. Or the Blazor community is this .NET thing. They actually ship a runtime of .NET as a in WebAssembly, WASM for short, so that you can just push C# code to the browser and use their own like different frameworks and stuff. This is becoming incredibly powerful because a lot of times on big, rich enterprise applications, especially like ones that have been around for a ton of time, there's like millions of lines of business logic baked into these apps. And if you were to rewrite this as an entire web app, you have to like redo all of that. But what if your business logic team could compile that down to a library, ship it to the web team? The web team can include it, just consume that library, and it just runs. So this is super, super new. There's a version of 1.0 in all the modern browsers, but it's super new and it's still kind of experimental.
One thing with WebAssembly, which is really, really compelling, is you keep saying compiled. So with JavaScript, everything is not compiled. So it has got a lot more bloat. So you're getting as most efficient as you possibly can get on the hardware. And
yep, you're jumping ahead slightly. No, you're good. Because the question is, why would I do this? And most of the use cases are actually kind of dumb. But the good ones are exactly the same. So high performance apps, that compiled bytecode, in some of the newer browsers, I've been seeing numbers where it performs like, they ran, what was the one, they were generating primes or something, and they had an experiment that ran, and if it ran in JavaScript, basically the same logic flow, just slightly different language, it would take like 30 seconds, and in the bytecode with the same logic flow, it ran in like, it was something like 40 milliseconds, right? So super high performing. Reusing the business logic we talked about, building things like machine learning or VR that are just really complicated and aren't going to be fun to write in JavaScript. This is the case that I don't like particularly because I've spent my whole life in JavaScript. The C# folks are crazy about how they're just not going to have to write JavaScript anymore until they realize that it doesn't do everything they want and they have to. But this is exciting, and that performance story is key. It's really, really high performing. So I'm going to pivot. Is that kind of fair with what you're saying? It's really impressive. Going to jump. So done talking about kind of code stuff. I want to spend a little bit more time, and we're almost done, talking about the Internet Engineering Task Force. So another standards body, but they own, so the Internet's a series of tubes, right? People still get that joke. I like to say they're Internet Engineering Tube Force. And hopefully it's stuck in your head now. They were formed in 1986. They own the Internet Protocol standards, IP standards. They seem to still do most of their stuff via mailing lists, not like GitHub. It was harder for me to find information about how they work, but it's also not, I'm a web person, not a protocol person. But they own this standard called HTTP2. And HTTP2 is a binary framing layer, which again, it means nothing to me. But they basically made changes to the way data is sent across the wire that could make significant improvements in how the web works. And so they set out to their goal was to, I think the number was like 40%. I don't think I have the quote in here. They thought that they could make a 40 or 50% improvement, Google is a big part of this, to the average website without changing a line of code in the web app. They could just make the site work 50% faster. And they thought what you'd get out of this, and it turned out to be true, is that you would get sites loading quicker, you'd get better battery life out of your devices because there's less time where it's broadcasting over its tiny little antenna. And you could actually like ship applications to weaker devices and have good experiences. And you could also do things around like multiple concurrent connections. Anyone seen that thing where you're downloading like stuff from a CDN and you go to CDN2 so you can get 6 more connections? Like, so you don't have to do that anymore. So there's a bunch of changes they've made to how this works to make web traffic feel more like traditional like network traffic. It requires SSL and it enables a bunch of other stuff too. It's super complicated because security researchers are a tough lot, but it requires security by default, and it's really powerful. But the interesting thing about it is it's all done at your web server. So you install or you turn on HTTP2 on a web server, the clients support it, and it just kind of works. So interesting story around this. Again, this is kind of the way the web kind of evolves. Google released something called Speedy, I don't know if anyone remembers that. And they shipped this, and they said, we're going to prove that 50% standard. And at the time, I was sort of like, Google's doing their thing again. They're shipping this garbage. It turned out that, do I have a quote in here? I think I took the quote out. So they shipped this Speedy thing, but they told the rest of the browsers, we're going to ship this. We're only going to push it to Google properties in our browser. So we're not trying to make it a standard. We're going to make it experimental, and we're going to tell people we're going to kill it. But they proved that this worked, and then they took it all back to the standards group and said, let's build a standard around this, and then all the other browser vendors got to chime in. So HTTP2 came from that by them kind of investing the development time, engineering time to build this. And what we got is now a protocol that, lets you have multiple concurrent connections. We'll keep connections alive. It reduces the header traffic if you're inspecting your web connection. Every request is like, here's who I am. Here's what languages I accept. Here's blah, 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 blah. And then I need to give you this ID number for something. On repeat connections, it can just skip all that. It says, you know who I am, and cut the web traffic down significantly just from that. So that's kind of happening behind the scenes, and that's something more like ops people care about, but it's cool. So last thing I want to talk about is, has anyone heard about this, the end of the new Edge browser? No. So Edge as a separate rendering engine, which they called Spartan for a while, is going away. There's a leak out on the internet. You can apparently download it. I'll show you guys a secret leak screen here in a second. But they are moving to Chromium, and they haven't announced when that will be, at least last I heard. But they think it's like summertime is probably reasonable for preview releases. It's going to have all of the rendering engine. It's going to the JavaScript rendering and web rendering of Chrome. The Chrome team is working really closely with them, and they actually want Edge team to push in performance improvements and other things they've done. But they're actually going to quit being their own rendering engine. So the world will really be Chromium and like Mozilla at that point, because all the other vendors seem to have gone to Chromium. So this is going to be a big change. There are probably like 5 sites out there that were built specifically for Edge. Those 5 sites are going to have a bad time. There are a ton of sites that were built for IE11. That doesn't change that at all. This impacts a few things. It impacts interoperability because the enterprise story and the Chrome story, because the Chrome story is almost every user, every developer uses Chrome, are the same now. So interoperability, having things just work, going to be significantly improved. That was the big driver. Standards compliance, because of that, it's going to be easier. You have 2 groups that are agreeing to put things in the standards. They're pulling all of the developer experience stuff across so that you can debug across devices easily. It doesn't change platform functionality. Like Google is built to integrate with Google. So like if you go to Gmail and any other browser, it pops up a little window that says this works better in Chrome. And it's BS because they're all freaking Chromium browsers anyway. But they're trying to build you, like the browser itself and the frame around it, they're still going to innovate. I would imagine that the Edge team is going to interact with like Office 365 and the Microsoft Enterprise story. So it's not going to affect that. And they're still able to innovate separately. So the Edge team, in some public announcements, said they're still going to try stuff that matters to Microsoft, matters to their customers. Mozilla's still going to do that. They're still going to bring features back. So I'm not supposed to do this, but I'll show you a leaked version of Edge. It's right there. Actually, that's just Chrome. I just took a picture of Chrome. I saw it last week. It looks like Chrome right now. So there are some stories and articles out there about it. One of the things that Edge had done a really good job with was performance and battery life. It sounds like that's all going to get ported into Chromium, so Chrome's going to get better at that too, which may mean it only takes 4 gigs of RAM now instead of like 16. So bring it all back together. A little bit of kind of how things are formed, a little bit of what's coming. Almost none of how do you do it, but hopefully you have some stuff you're interested in. That's it for me. I'll put slides up on jaredthenerd.com. There's a recent version of this. I'll hang out. I've got some t-shirts and stuff. I don't know if do you want to give them away a certain way or how do you?
Yeah.